Hello, I'm David White from the ARC Group, and I'm speaking today with Rob High, who is the CTO for IBM Watson, and we're going to talk about cognitive computing. Rob, welcome.
Thank you, Dave.
So Rob, CTO of IBM Watson, tell me a little more about what that role is specifically and what it encompasses.
Yeah, it's mostly about setting the technical strategy for this idea that we call cognitive computing, to try to identify what the underlying technology trends are, the utility and application of that technology, and to solving for the problems that we think that cognitive computing can help with.
Okay, so to me it sounds a little bit like machine learning, and I know machine learning in various guises has been around for 30 or 40 years, I think, the algorithm. So what is different specifically about IBM Watson and the approach that you take?
No, you're right. Machine learning really is at the heart of what we do, but the thing that really makes it different is that this is machine learning as applied to spaces that humans are experiencing. It's about our human condition. It's about the language that we use to express ideas. And using machine learning to recognize the patterns of meaning in the signals that exist within that linguistic analysis, within that linguistic expression, is driving semantics, not by depicting or pulling apart the individual words, but really by trying to understand what was being conveyed and what were the patterns that were exercised within that linguistic expression that really get to what I mean to be saying. And when we do that with people, with the way people talk, do that with literature, do that with images and with sound, now we're getting to the essence of what really drives our ability to understand each other and to be able to convey information and be able to drive out of the vast quantities of information that are out there the things that are most relevant to the decisions we need to make.
Okay, that's certainly different and interesting. So can you give me a specific example then of the kind of problem which you might solve with Watson, which you couldn't solve with any other traditional technique?
Yeah, so it's important to understand, first of all, that what we're facing as a society is just a massive explosion of information. And that in that information are buried the details and the little specifics that are important to us that, frankly, we're losing the opportunity that we simply don't have the time to go back and read and find. So all this information is flowing. We don't necessarily see it. We don't necessarily know how to get to it. So having a cognitive system that can go in and read that material for us, to be able to recognize whatever that is important to us, to be able to pull that out and bring it to us when we make these decisions, allows us to make more informed decisions, to be able to understand perspectives that would otherwise be blind to us, to be able to bring ideas to the table, and even to inspire us to come up with new ideas that we might not have thought of before.
Okay. Yeah, that all sounds very different and novel. So can you give me maybe one or two specific examples of where Watson's been applied in traditional industrial settings, such as oil and gas or manufacturing or supply chain, for example?
Yeah, so the one that is really prevalent right now is one that I think we would all recognize as being a very common issue. And that is when we're trying to maintain the equipment that we're responsible for in these kinds of environments. You know, one of the things that mechanics have to do is to go in and, first of all, identify what the problem is, diagnose it, determine what they're going to do to repair that situation. And of course, that draws heavily on their own knowledge, but it also requires that they go out and find literature, to find the repair manuals, to find the right section of the repair manual, to be able to understand how these systems interact with each other. So if instead of having to go through the manual process of finding that information in the repair manual, we could simply turn to Watson, explain the situation as we have discovered it, as we have evaluated it, and have Watson go out and find for us the right section of the repair manual to bring us to the right place so that then we can continue to do our job. Then it saves us all that time that would otherwise be spent wasted trying to find the information that's relevant to us.
Mm-hmm. I think you're right. That's a good example, and that is a particularly pressing problem that we see a lot in industry as well. So that's very good. So looking ahead maybe 2 or 3 years then, so what's on the roadmap next for IBM Watson? What kind of problems do you see evolving towards, and what kind of capabilities do you look to develop in the future?
Well, since the fundamental nature of Watson and cognitive systems in general is to really kind of sift out the noise from the signal. By doing signal analysis, that's really what these things are doing. They're picking up, in the case of linguistics, the linguistic signals that convey meaning, or in the case of evaluating any other human condition, it is about trying to test for what are those patterns of signal that most represent meaning. It becomes very obvious that the next logical step for these cognitive systems in the IoT space is to look at all the signals coming off of these devices, and not just simply to recognize them for what they are individually, but really look at the patterns of those signals. So if you've got a device that is at some stage of failure, sometimes well before anybody else might be able to recognize that failure, or even more so, even if it's not failing, but whatever you're using that device for. Let's say you're on a drilling platform, the little signals of sound, of vibration, of interaction between this device and that device might suggest something about either a future failure or perhaps even just an error that's being made in the process that, if detected early enough, could be corrected and save everybody a lot of time, a lot of money, avoid downtime, avoid having to recover from mistakes, et cetera, et cetera. So it all comes down to, can we apply this technique that we now have harnessed for understanding language, and now also essentially understand the language of machinery, the language of process, the language of the environment that we exist in, through all the senses that these devices have, and for the data they bring in.
Okay, that's great, Rob. Thank you very much for your time.
Thank you so much for having me. I appreciate having the time here to talk to you today.
You've been watching Rob Hai, CTO of IBM Watson, and we've been talking about cognitive computing. Thank you so much for your time.